Have you ever wanted to be a lunar explorer, without having to actually leave your desk? Well, today we're diving into a really powerful AI tool that pretty much makes that possible. We're going to break down how just about anyone can help map the moon using nothing more than their computer.
I mean, just think about that for a second. It sounds a little like science fiction, right? The idea that you could have the power of a research scientist analyzing these super detailed images of the lunar surface, well, it's not fiction anymore. It is absolutely a reality, and we're about to see exactly how.
You see, the moon's surface is kind of like a history book for our entire solar system. Every single crater tells a story about ancient asteroid impacts, or volcanic activity, or cosmic events that happened billions of years ago. But here's the catch. Manually finding and cataloging all of those thousands and thousands of craters, it's a monumental, incredibly time-consuming task for scientists. So how in the world do you solve a problem on that scale? Well, you build a smarter tool. And that's where this new web application comes in, developed by Mihir Panchal at the ISRO Space Application Center. It's designed to do all that heavy lifting and unlock these lunar secrets way faster than we ever thought possible. Okay, so the brains behind this whole operation is a deep learning model called YOLO-based. Now, the best way to think about it is like a super-trained digital eye. This AI has been shown countless, and I mean countless, images of lunar craters. It's learned to recognize their unique shapes, their shadows, everything about them, until it can spot one almost instantly in any new picture you show it. So what are this app's superpowers? Well, it's all about speed and giving you control. You upload an image and bam, the AI instantly finds the craters. But here's the cool part. You can use a simple slider to fine-tune how sensitive it is so you get exactly the kind of results you're looking for. And maybe most importantly, you can export all of that valuable data for real scientific work. It's a seriously powerful and easy-to-use package. All right, so we've seen what it can do, but how does it actually work? I mean, how do you take a simple picture and turn it into valuable scientific data? Turns out, it's a surprisingly simple process. It's really just a straightforward four-step journey. First, you drag and drop your lunar image. Easy enough. Second, you tweak that simple sensitivity slider. Third, you hit Analyze and just let the AI work its magic. And finally, you can see the results right there and download your very own annotated crater map. It's really that simple. So let's talk about that sensitivity slider. What is it actually doing? Well, think of it like this. A low setting is like casting a really wide net. You're going to find a lot more potential craters, which is great for a first look, but you might get a few things that aren't actually craters. On the other hand, a high setting is like being a precise surgeon. You'll get fewer results, but you can be much more confident that what you found is the real deal. And this is absolutely brilliant. You're getting so much more than just a picture with some boxes drawn on it. The tool spits out a JSON file, which is just a super clean, organized data format that computers love. It gives you the exact coordinates for every crater and the AI's confidence score for each one. This is the kind of hard data that researchers can plug directly into their own models for some really deep analysis. Okay, we've covered the what and the how. But now, let's get to the big question, the why. Why does a tool like this actually matter, not just for PhDs and professional scientists, but for, well, everyone who's interested in space? It really all boils down to this. It's one single tool, a single, powerful, and most importantly, accessible application that puts the power of lunar mapping into the hands of countless researchers, students, and amateur astronomers all over the world. It's like one key that unlocks this massive door for so many people.
You know, the real impact here isn't just about doing things faster. It's about accelerating discovery itself. By automating all that slow, tedious manual work, this tool frees up human brains, the scientists, to focus on the bigger questions, like, okay, what does all this data actually mean? And what can it teach us about our place in the universe?
And ultimately, this is the key takeaway, what this is all about. It's the democratization of science. This tool just breaks down barriers. It allows a high school student, or you, or me, or an amateur astronomer to use a sophisticated AI model that, not too long ago, was only available to these huge research institutions. The power of space exploration is literally in more hands than ever before.
And that, of course, leaves us with one final fascinating thought. This whole thing starts with lunar craters, but what's next? Will tools like this help us spot potentially hazardous asteroids? Or maybe analyze weather patterns on distant exoplanets? Or even find brand new galaxies hidden deep in space? This digital eye is really just beginning to open, and the cosmos, well, it's waiting.